Okay, welcome everybody to this last session of the day, and welcome to all the audience to this workshop. We will gonna be talking about machine vision and advanced data analytics, and what these two topics are important. Why these two topics are important for both the ICT and the industrial companies. My name is Stefano Salvador, and I will be moderating this workshop. I will just give you a quick run of the agenda. So after my brief introduction, we will host Harald Piringer, the CEO of Visplor, who will present some case studies, some practical example of visual time series analysis in the context of Industry 4.0. Then we will move on to Alessandro Liani, the CEO of Video System, who will talk about some applications of quality control, machine vision for quality control in industrial processes, and he will also present us some interesting EU funding opportunities. And last but not least, we will have a speech by Paolo Paniek, who will briefly present you what the European Digital Innovation Hubs are and why are they relevant for ICT companies. Lastly, we will have a question and answer session, but please feel free to use the Slido tool at any time. We will collect the question as they come up. And if you want to address a question to a specific speaker, just feel free to do it anytime. Okay, just quickly, my introductory part. We are talking about machine vision, data analytics, artificial intelligence, which are buzzwords, keywords that are on the mouth of everyone lately and are really an interest point for all the industries and different sectors. But what is the real demand for these technologies in the industrial sector? So for the ICT clients, for what we as ICT operators see as our utilizers. There are many points of view of that, but we will give you some photographies of really our experience. Who am I? As I said, my name is Stefano Salvador. I'm working at Area Science Park, which is a national research and innovation institution in Italy. We are based, our headquarters are in Trieste, so in the upper northeast corner of Italy, not far from Austria. We were founded in 1978, and we are the manager of the first and largest Italian science and technology park. Our mission is to help developing the economic system by pushing innovation and technological research. Since 2018, we are focusing a lot on helping digitalization of industrial companies, and we are the coordinators of the regional European Digital Innovation Hub, of which my colleague Paolo Paniek will talk a bit later on. So, back to the topic. So, is there a real demand for these technologies on the industrial sector? There are many trends and reports on the global level, but we wanted to give you a short glimpse on a really local and practical example. We wanted to know within our backyard, our region, Friuli Venezia Giulia, how the situation was for industrial companies. So we conducted in this last couple of years a series of assessment campaigns. We wanted to visit industrial companies to check how digital they are, what kind of technologies they are using, and where they are lacking. So we visited around 170 companies, and both from large multinationals, from like example, Electrolux, the local plants, to really micro companies and everything in between. And what we found is that the main area of interest, so the main lacking point for most of the companies, especially the SMEs, is still the integration of different systems. So between the IT, the operations, they have many different IT systems that are not really talking to each other, are not really connected. So this is the first focus point. But the second one interesting is data analytics and AI. So there is a real demand from all sides of clients for this kind of technologies and these opportunities. The third one, you can see from the graph, is what we call process technologies. And within that process technologies, which means for us, the IT that goes inline, the digital technologies that is embedded in the production plants, the focus is really on quality control. It's something that all companies are recognizing as a turning point, a key area of interest. And within that, machine vision is the first technology that comes to the interest and what the companies are asking. This gives you a glimpse. Our regional situation is similar to many different regions in Europe. We know that in Europe, the companies are quite smaller, and that this is the landscape in which we are moving. We wanted to see also another thing. Is there already an ICT offering for these technologies? Is the offer mature? Is it already enough to cover all the demand? This is an interesting fact we saw. We interviewed 190 ICT companies within our region, asking what they are developing, what they are proposing to their clientele. And you can see it on the right of the screen, which technologies they are proposing. And on the left, you see what we suggested to the industrial company to improve. And we can see that there's a lot of interest in our region, for example, on virtual reality and augmented reality, which is actually not a technology that the industrial companies there are ready to implement, to buy. While the data analysis is not so high in the offering, but is probably something that is much more needed. What is the message from our side and for this is simply that the market demand is there, it's clear, and there is also still space in the ICT domain to still grow on that. I will just stop here and leave the floor to the more interesting practical example from companies. So welcome again to Harald Piringer, CEO of Visplor, and also himself a researcher coming from VRVIS, which is a leading Austrian research institute. Please, Harald, the floor is yours.
Okay. Do you see my screen?
Yeah.
Okay, great. Thank you. Okay, so good afternoon, everybody. My name is Harald Piringer. I'm the CEO of Visplor, and I'm very happy that I can tell you a bit about visual time series analysis for Industry 4.0, giving you some short glimpses on case studies. So as a short motivation, in recent years, many companies have made massive investments in the digitization of production lines and related initiatives. And there are studies actually that show that using the new data sources is often slow to arrive in daily practice. For example, a study by the Digital Analytics Association Germany concluded that 60% of industrial companies actually consider themselves good at collecting sensor data, but only 32% derive the desired benefits from it. So why is this? One reason we see over and over again is the following. To exploit today's massive data, you need to make two ends meet: domain knowledge and advanced analytics. For small data, Excel might have been enough, but for massive sensor data, It's actually not. And that's the point. It's simply inefficient when domain experts start analyzing millions of sensor values with Excel. At the other end of the spectrum, however, data scientists often lack the domain knowledge to interpret data and patterns. So they might be good at finding patterns, but it's often hard for them to tell if these patterns are really relevant to the business. So actually, it's all about the golden mean. And how can you get there? For domain experts, the easiest approach is to give them intuitive tools. Tools which enable them to do advanced data analytics themselves and thus become a kind of superstar. And one way to bring data scientists closer to the center is to make the communication with domain experts about the data more efficient. And that's exactly where Whisplor comes in. It makes fast and easy use of advanced analytics on massive sensor data accessible to domain experts. And on the other hand, it makes it easier for data scientists to understand and prepare their data. So just very briefly about Whisplor. Whisplor is a visual analytics software for industry and the energy sector. It's a fast and easy way to analyze large time series data. Whisplor reduces the effort for complex analysis by orders of magnitudes so that the focus actually stays on solving the real problem and not on data wrangling or exploring data. And Whisplor integrates well with files, databases, and even environments such as Python, MATLAB, and R. So let's look at a specific use case. As it was said in the introduction already, artificial intelligence is now becoming absolutely ubiquitous. Everyone's talking about it. However, getting a good AI doesn't often work out of the box. It's actually quite a complex development process to get there. And in this process, understanding and preparing the data account for a large part of the work and the effort. Many studies say it's up to 80%. And a large part of these 80% is a task called data labeling. So what is labeling? Actually, AI is about learning from data. So the AI you will get is only as good as the input data. And when you capture raw data from sensors, be it images or be it sensors you will find at machines, it's up to the humans to first tell the AI what this data actually means, so that the AI can learn that later on. And this process is called data labeling. Careful labeling is one of the best things you can do to get good AI models. Unfortunately, as humans must be involved, it can be very time-consuming for large sensor data. And here is a specific example from Verbund, Austria's biggest hydropower supplier. It's about condition-based monitoring of a power plant sensor. It's a temperature sensor. And this is what the raw data of the sensor looks like over 4 years. So when you run AI on that data, you would get garbage out, because many things would only distort an AI model. For example, that straight line here is a long revision of the power plant. So basically, there is no real data at all during that period of time, even though there is data in the database. Then all these spikes here are turbine startups and shutdowns. And even if you look at the rest of the data, which corresponds to the normal operation of the power plant, it turns out that only the time after the revision is usable. So this is the green part of the data. This already is a form of labeling, as we tell the algorithm which parts of the data it should actually use to build a predictive model on. And with Whisplor, getting this validated labeling took less than 10 minutes and can be done live together with a process expert can interpret these patterns and the data. The next use case is from the process industry. we have sensor data from a continuous production process. And in this process, there was an anomaly from time to time. The goal is to find possible root causes of these anomalies. Let's look at this short video to give you an idea about how easy this can be addressed. So here on the left-hand side, you see here on the left-hand side, you see a large set of sensors. It's actually more than 300. And one of them is a chemical target indicator. This is what you see here on the right-hand side as a time series. And we zoom into this sensor, you see that from time to time, there is an anomaly, like here. And what you can do now is you can simply mark, based on the domain knowledge, those anomalies in the data. This is very simple. You can use the visualization here that you can intuitively select what you're interested in. And in this case, it's the anomalies. And if we scroll a bit further to the right, we see that there are some more anomalies that can also be marked. Okay, and once we did this, now there are some convenient features like the compare here that you see. So this brings us those patterns next to each other so that we can compare the anomalies. But more interestingly, now this view on the left-hand side, this now gives us a guidance which of these 300 sensors here is actually has a potential to explain the root causes of these anomalies. What do you see here? Again, you see that one line here corresponds to a sensor, and each column here corresponds to one of those 6 periods that were just marked up in the graphics before. And the color indicates if there is a strong upward trend, which are red cells, or a strong downward trend, which are blue cells. So, for example, if a line would be red all over the time, it would mean that there is a large upward trend for all 6 of those periods. In fact, this is not the case here, but the algorithm automatically ordered those sensors on top where they show often very rapid changes. And continuing the video, we will see this, that when we pick the first sensor up here and just additionally visualize it, we see that actually here we see such a spiking behavior just before the beginning of the anomaly. And this seems to be each time, apart from the 5th time where it's actually a sharp drop. We can visualize this a bit more nicer way. And we can also add more sensors here. So for example, the one below, which actually is a very similar pattern, and even more to quickly identify those sensors that can explain or that can potentially explain what which sensors could be indicate root causes of these anomalies. So this is another example where you need actually both deep domain knowledge about the process, because without interpreting what these sensors are and what they mean, you wouldn't be able to identify the root causes. As we heard about process optimization before in the intro, but you also need analytics, because you need analytics to be efficient, to work with the data and to be guided to those sensors that you need to look at. So next one, here is a similar use case from Inyo Jembacher. Their maintenance department had recurring problems with bacterial infestations in the cooler. And the goal was to identify if some sensors show patterns before the problem, so that they can predict the problem and take countermeasures earlier. Also in this case, it took just a few minutes to find patterns that indicate the problem in advance. All there was to do was to select the periods preceding the bacterial infestations in the graphics, as we have just seen in the video, and intelligent algorithms suggested sensors to look at. And that's what they found. As you see in the picture, the red sensor is decreasing for several days before the bacterial infestations, while the blue sensor tend to increase. We could confirm this predictive significance of the pattern, and this knowledge was the basis for them for auto-alerting and appropriate countermeasures. And this finally led to increasing the average maintenance interval from 19 to 49 days. So this was really an important finding for them. So far, all use cases that we have seen were on continuous sensor signals. Let's finally look at the fourth use case from discrete manufacturing, namely the optimization of a die casting process. This is also a very complex process with up to hundreds of variables measured for each produced part. Whistler helps process technologists to optimize the process by revealing complex relationships between the measured variables. That is the key to improving product quality, reducing scrap, and increasing energy efficiency. This quote from a process expert at the Austrian Foundry Institute sums up this. With Whistler, they were able to identify and to recognize correlations that they couldn't do before with any other statistical software or other tools. And the result was that they could reduce the heating energy by approximately 5% and mold wear by approximately 4% without any negative effects on the scrap rate. So as you see, Whistler is in use by quite some companies. These logos are just a small sample of them. Basically, you can cluster these in three groups. They are industry, energy, and research and development. And in industry, maybe it's worth pointing out that Whistler is suitable both for continuous process industry, as for example, the paper producer Mondi here, as well as for discrete manufacturing, like for example, the foundry Georg Fischer. Finally, permit me to say a few words about ourselves. We are a spin-off company of VIA-Vis, which is Austria's leading research center in visual computing. We have developed the software in over 10 years, have applied research at VIA-Vis together with innovative Austrian corporates such as AVL, RHA Magnesita, and Austrian Power Grid, and have now commercialized the results. We had a funding round in February from E2V, a major European venture capital firm. And if you're interested, we'll be very happy if you have a look at our webpage, whistler.com, where there's also where there are more use cases and videos, and there is also a free version where you can also have a look at your own data. This is possible. You can look at your own data. So let's conclude with a quote by Galileo Galilei, who said that all truths are easy to understand once they are discovered, but often the point is to discover them. And this, I think, sums it up very nicely, because Whistler is a tool that helps domain experts to discover truths in massive sensor data. Okay, with this, I want to thank you for your attention. If you want to get more value out of the data, I'd be happy if you get in touch with us. Thank you very much and enjoy the other talks.
Thank you very much, Harald. So we have seen that not all data is equal, and that the preparation of data is an essential part of any data project. And I think I will come back with some questions for you in the question and answer session later on. But let's now move to Alessandro Liani, founder and CEO of Video System SRL, an Italian company which will shift a bit the speech from the pure software to the machine vision. So from the data also to the machine vision side with some real case, so real use cases from his company experience. Alessandro, please, the floor is yours.
Thank you. Good evening, ladies and gentlemen. This evening I will talk you about the capability of artificial intelligence applied to machine vision applications, and in particular on manufacturing quality and process control. Video System is a small medium enterprise established in 1993. And starting from 2001, we start to apply artificial intelligence on machine vision quality control solutions. And starting from 2015, we start to apply deep learning technologies, a part of machine technologies. And Video System is composed of different divisions dedicated to different industrial applications. And we have a huge network of university and research centers around Europe that collaborate with us for research and development of new technologies. We are engaged in many Horizon 2020 projects, and last year we won a Seal of Excellence in a small instrument project with our Apicus technology that applies robotics, artificial vision, and artificial intelligence for quality control. Our solutions are installed all around the world, especially in steel and hollow glass plant for quality and process control. Today, we have more than 200 tailor-made applications where the goals are to have a good effectiveness, the capability to detect the defects with a good efficiency. This means with a low ratio on false positives, because what customers are looking is systems that are able to detect defects, but with a very low ratio of false positive for having a high performance of the plants. Today we talk about 3 use cases. One of the bakery sector. In this case, the customer was looking for a system that is able to detect the good production of bakery products. The project starts with the capability of detecting the quality of products, looking at the size and the good cooking of the surface of the product and the geometrically aspect of the product. And with this first project, we find also data about the process, and we identify that the central part of the line produce very good products. On the borders, there is some problems about correctness of the final product, and this permits to the customer to optimize the production, working on the process data to align all the lines on the capability of produce good products. And thanks to the fact we acquire a very big amount of data, of pictures about products, the second step was the capability to develop an engine that is able to acquire the picture from the line. An artificial intelligence engine using this picture produce the picture of the product that is how this product must be for be a good product. And using this picture, we are able to identify contaminants on the product. Also, when the contaminant have a color or a characteristic very similar to the real product. This type of application is not able to be solved using traditional machine vision technologies, and thanks to deep learning, we solved this problem of the customer. The second is on the hollow glass sector. And in this case, the system is able to identify very small parts of glasses present on the bottom of the product. And in the pictures below, you can see the difference using standard machine vision algorithms and the capability of a deep learning system to identify other contaminants that are not identified by the standard algorithms. And the capability of a deep learning technology is about 5 times on effectiveness and 10 times lower on false positive generation. The third is on the steel. In this case, is a system that acquired the raw surface of a rail and identify very small cracks on a very complex surface at a very high speed. The system is capable of acquiring at some meters per second of movement of the product, acquiring the surface, and thanks to a deep learning engine, identify very small cracks. Also in this case, using traditional technology, it is not possible to define a threshold of what is a defect and what is not. And this is a know-how video system have grown in the last 15 years. And today, video system is engaged in Horizon 2020 programs, and especially on one zero defects manufacturing platform that provide this year 2 open calls. One is closed some weeks ago with 58 proposals submitted. The next one is open at the end of August and close at the end of October. And in that case, companies can participate to open call with a project worth between 50,000 to 150,000 euros per each project. And the project can be focused on testing our platform or developing components for the platform and be part of the ecosystem of a zero defect platform. Thank you.
Thank you very much, Alessandro. You were actually quicker than the expected time.
Yeah.
So thank you very much. We will have more time for discussion later on. I can see that some questions are coming also from the Slido, so we will keep them for the later Q&A session. And I would now give the floor to Paolo Paniek, who will, let's say, pick up the line from Alessandro, from the last part of Alessandro's presentation, and we'll talk about some European opportunities, so European Digital Innovation Hubs, and the related possibilities for ICT professionals and companies. Please, Paolo.
Hello, thank you very much, Stefano. Trying to share my screen. Can you see it?
Yeah.
Yeah, okay, thank you. So my name is Paolo Paniek. I'm a project manager of IP4FUG, a digital innovation hub based in Italy, Northeast Italy, in region Friuli Venezia Giulia. And I will give you a brief view of the evolution the process towards the EDIC, what's going on, so the process from DICs to EDICs, and the services that the EDIC can provide for ICT companies. So basically, we are right in the middle of this transition process. and basically we are waiting the call. As you see down in the select box, we are waiting the received call for the end of May. So it's very imminent. And basically, at the moment, we have 500, more than 500 digital innovation hubs, and that grew in the last 4 to 5 years. And this, let's say, ecosystem of digital innovation hubs is quite differentiated inside. I mean, between the different digital innovation hubs, there are substantial differences in how they work. So basically the European Commission needs a more standardized counterpart in developing of their policies and measures to support the digitization. And that's why basically the European digital hubs are developed right now. Basically what they need, when I say standardized, I think about basically 3 main elements. Standardization of function and services, standardization of geographical coverage, and basically a regional coverage, and a standardization in the sense that they have to have strong specializations in some crucial technologies. So basically, what is the European Commission is expecting is going from 500 and 400 digital innovation hubs to 210 European digital innovation hubs with a proxy of one European digital innovation hub per region, basically, and to create one functioning network of these European digital innovation hubs. The Digital Euro program will finance this, basically this transition, this evolution, and basically by upgrading, financing some development of services and the capacities of European digital innovation hubs, and financing networking. So basically that this network will be functioning, exchanging and importing and exporting know-how and knowledge. So basically, when we talk about standardization approaches of the ethics, we think mainly of 2 main standardization elements. First of all, it's the service structure, and second, it's the specializations. So as far as the service structure is concerned, European Digital Innovation Hub will have to develop basically 4 different group of services. One, it's more technological, and it's called Test Before Invest. Basically, the companies will have the possibility to access some demo plans, demo infrastructure, and to have some more technological support services. Then we'll have some skills and trainings, which are also fundamental because, of course, to digital transformation needs also an upgrade in digital skills, both for the businesses, but also for the EDIC itself. So train the trainers will be there also important. And of course, support the fine investments, because digital transformation must be financed. Businesses must find their, let's say, funds to transform, to scale up, and so on. And last but not least, the innovation and ecosystem and networking services. And these are the services that should provide the development of the network, the European network, and the functioning of the network, basically by brokering and networking activities. So talking about specializations, European Digital Innovation Hub will have or must develop some specializations in at least one of the 3 main technologies that has been defined as crucial by the European Commission, which is high performance computing, artificial intelligence, and cybersecurity. This will serve basically to develop kind of a lighthouse function for all the European digital innovation hubs that will be will have the aim of attracting also from other territories some clients, thus basically developing a European market of digital transformation services. Of course, European Digital Innovation Hub will have also to develop some other technologies, some smaller specialization, application areas, and for different sectors. So an example can be a strong AE capacity coupled with simulation for Industry 4.0 and for the textile industry, for example. So basically, edX are adding a European function, a new function to the functions of the digital innovation hubs. So digital innovation hubs have today a more local function. They act as a one-stop shop to support the development of the market of digital transformation at local level, regional level. But edX will add this EU basically dimension and function, and will, of course, help in access, we will act as an access point to European network of edX. Will actively network with other hubs, sharing best practices, bringing companies into contact with companies from other value chains or in the same value chains, and so on, and broker, of course, between public administration and companies. Here you have a schematic overview of what's all about, and you see that there's going to be a DTA, which stands for Digital Transformation Accelerator, which will be the body that from the, let's say, the center from Brussels will stimulate the networking activities between European digital innovation hubs. So cooperation, it's the real value added that the Commission is looking for, because they would like to reduce overlapping investments. They would like to stimulate specializations and generating synergies between different regions and different, let's say, ecosystems. So the drivers of this cooperation is, of course, specialization, so the lighthouse factor. And of course, by leveraging on complementarities and on similarities. And the Commission has developed also the concept of corridor, and corridors will be these channels between, among which the knowledge and services will be exchanged between European digital innovation hubs. And the DTA, the Digital Transformation Accelerator, will be the orchestrator of this network. So as we are focusing a little bit more on ICT today, dominantly ICT, I tried to summarize here in this slide some services that would be interesting specifically for ICT companies. So for Test Before Invest, of course, access to advanced competencies and facilities, some support to business model development and IPR support, for example. In terms of investment, of course, support to access financial institutions, scouting calls, partner search, and access to programs like InvestEU, Startup Europe, and participation of Cascade funding that Alessandro Liani was mentioning before. So ecosystem and networking services, of course, these are really appreciated by ICTs, and of course, this is based on matchmaking and brokerage events. They can also provide demo use cases for the Test Before Invest activities, and of course, all kinds of brokerage and matchmaking, like accessing also challenges launched by industries and so on. In terms of skills and training, of course, access to specialized advanced training, and also job placement services. For my last slide, I would like to just offer you a brief overview of IP4. So IP and one specific service that is dedicated to the ICT companies. IP4, it's a regional digital innovation hub that it's operative from 2018, and it's started already as a regional digital innovation hub, so federating all the main actors active in the digital transformation support services in our region 3 with Julia. And it's made up of 4 technological nodes, which are basically the access points to the services. So our 4 physical places with 4 labs that are specialized in some of the digital technologies that you can see there. And we are working also on 4 thematic sectors: manufacturing, construction, smart health and life sciences, and smart mountain, which is basically energy and environment. But most important, we have 2 technological specializations, like the top end specialization that we were talking before, and that constitute our lighthouse. So we have a combination of HPC and artificial intelligence services applied to life sciences and specifically genomics. So the service I would like to explain a little bit, it's digital solutions. So digital solutions, it's basically an open call for ICT solution providers, and we use it to collect innovative or less innovative solutions, but of course we prefer innovative solutions to feed our use case libraries in the demo labs. And these libraries can be then used for the demo activities with our clients, user clients. And of course we can show different solutions, and after an analysis of the needs of the company, of the potential user, we can assess which can be the provider that's most fit to the needs of the company. And of course, bearing in mind always that the EDIC must be very neutral in terms of kind of brokeraging, matchmaking different companies, and hopefully the happy end is a contract between the user and the provider, benefit of both. So this is basically my presentation. I'm here to answer some questions, if any. Thank you very much for listening. Thank you.
Thank you, Paolo. Thank you very much. Now there should be, we're supposed to have another speaker, Dr. Katja Bühler from VRVIS, but unfortunately, due to some unexpected last-minute circumstances, she could not join us today. So we have a bit more time to go a bit deeper also in the use cases that we were presented, and to answer some of the questions. And so I will try and go through some of the questions that we collected from Slido, and I will go in chronological order. So starting with Harald. So we have one question for you on the technical side. Does the software, so does your solution work with any kind of sensor? Or are there some technical, I don't know if, Harald, if you can explain a bit more, maybe also the layers that your solution is working on, please.
Yes, basically you can import data from different sources. This can be as simple as a CSV file, but it can also be directly from a SQL database. It can be, for example, with a direct connection to the iSoft Pi system, which is a big IoT platform used in manufacturing. And you can directly send data from Python, MATLAB, and R. So, for example, if you have the data in one of those data science environments, we have an API in place where you can directly send the data over to WISPLOR, analyze the data there, and get things like, for example, data labels back to Python without any files or databases involved in between. So it's a direct connection.
Okay, thank you. Thank you for your answer. And for the audience, obviously, if other questions come up, you can still continue using the Slido tool. So I will now go to one question for Alessandro that we got, and it is, what was your approach for detecting the cracks? I think it's referring to the, I guess, to the hologlass use case, or maybe the rail.
Or the rail one.
Okay. Did you train your algorithm on good images and then just highlighted the anomalies? So I guess if you can explain a bit more also maybe what you were referring to, the difference between like traditional approach and the advantages of the new machine learning and deep learning paradigm.
Yes. Okay. In the case of the rails, we use label defects to teach to the deep learning engine what is a crack, and the system start to understand what is the crack. The same for the class. On some other use cases I didn't present today, we work with a different approach. In that case, we develop AI engines able to detect anomalies on what is the good product. It is very problem depending the solution and the approach we take on the problem. For this reason, it's very important, something that Harold talked before, that is very important to work together, the customer and the technology expert. It is not possible to find a final solution only using the knowledge of one of the two sides of the problem.
Okay, yeah, clear. So there's no one-stop solution, and if we have time, so I would also take the chance to go a bit deeper on this, the last part you mentioned, so that this kind of projects, both in the industrial, so embedded AI, as in pure data science and data analytics, it's important to mix.
Yes, I think like I think about Harold work is we use collaborative design for defining the best solution to the problem, using the know-how of the customer that knows the process, that knows the product we have to control, and applying the technology that is our know-how and our part for finding the best solution for the quality control system in our case.
Okay, clear. But then, Harald, you were mentioned many times, so I will come back to you. And I have like a personal question. So as we are talking with an audience of mainly IT professionals and companies, let's keep the supplier perspective. So if we wanted to start a data project, so one of your projects with a new client company, who would you say is the best contact person, or what is the best approach to convince, to persuade a client to actually invest and start in such a project? Because as you said in your presentation, they are sure that they have enough sensors and enough data, but they are not so capable of really exploiting it and keeping and getting all the relevant information. So who would you speak to if this was the case?
Yeah, thank you for that question. Of course, it's a bit different from customer to customer. Companies are structured differently. And of course, you need buy-ins from, let's say, the management and also the IT department. But typically, I think the starting point should actually be the business unit, which really wants to solve a specific problem. Because if you have lots of data, you can analyze more or less everything. But I mean, maybe I bring a short anecdote here from one of our customers. It's RHI Magnesita, and they have had a data science project with an external data science company, and they were analyzing their machine data. And at the final presentation, there was a big finding that at a certain time in the morning, there was a high probability that machine stopped. Yeah, this was statistically absolutely significant, but the presentation, people started to laugh and say, yes, this is because this is the time we have lunch break. Yeah, and this is actually the point I want to make. There is a big difference between significance And this is what data science is typically about, finding significance and relevance, business relevance. And really to combine both, you need to start with the business units who really have a problem and who want to solve something. But of course, you need in case you already have it, and larger companies, in some cases you're not, you of course should also have someone who is a bit more mature in advanced analytics. So that the data scientists, be it external organizations or be in an internal data science department, or be it also a bit of help, of course, by tools like Visplor. In many cases, for complex projects, you will need all of them. You will need the domain expert, you will need the data scientist, and you will need tools to make the working together efficient. And then on top of that, of course, you need the okay from the management, you need the okay from the IT department, and yeah, that's how projects grow. But still, I think the starting point should be the business unit.
Okay, so it's always then important to first really see the problem with the ones that are subjected to the consequences. So yes, really to start from there. Okay, thank you very much. We have another question for Alessandro from the audience, and it says, what kind of companies can access the open calls? So I think it's referring definitely to the zero defect project. So Alessandro, maybe you can explain how it works.
The open call is more focused on SME companies, but it's possible to find the regulation of the open call on zdmp.eu website, and it's possible to make a consortium of maximum 2 players. And companies can be final users that want to test the platform on a real problem, or developers that can be develop components for the platform. The platform is essentially based on Docker technology and web-based user interfaces and IoT data exchange.
Okay, clear. Thank you. Is there a standard size for the grants? So are all the grants equal?
The grants cover maximum the 70% of the costs, and are between 15,000 to 115,000 euros maximum, and depending on the effort declared on the proposal. And the time is 9 months for making the project on the subcode.
Very well. Okay, very clear. Thank you very much. Also in your case, I have a personal question, so something that came to my mind. And so you are involved in the project as a partner, and you are a small and medium enterprise, like really technologically focused. What would you say is like the advantage? So would you recommend for companies such as yours to join such a European project, or what are really like the main advantages? What do you expect? Also, because you said that you have quite a long history of research projects and cooperative projects also in the past. So just for the audience, if you have like a couple of learning lessons or what they can expect from such projects, I think it would be helpful to share.
Yeah, in my opinion, for a SME company, participate to a European project is a very good opportunity to grow in knowledge, to know how to collaborate with the other European companies and that have a different approach to the work. and it is a very good opportunity for working together and working for problems and challenges that Europe is looking to solve in the future.
Okay, thank you. So it is a good opportunity, and so let's hope that also many other, in our case, Italian companies join such European projects, because it's not so common, especially for the smaller ones. Let's go then to some questions for Paolo. We have one question from the audience that asks if the slides from your presentation will be shared afterwards. So.
Yes, I do not have any problem with that. I will give it, I don't know, to the organization, or also you can contact directly. You can contact me directly, so no problem.
Okay, fine. And yes, we also got from the organization the confirm that the slides and the materials, also the registration of the workshop, will be put on the B2Match website, so on the event website after the event. So thank you for sharing. And in all our slides, you will find the direct contacts. So please feel free also to contact any of the speakers if you have other requests, or if you're interested to get in touch for potential cooperation. Also for Paolo, I think, like, thinking of what the audience would be interested, I think, in this European Digital Innovation Hub instrument. Obviously, you have the experience of our region, so one example, but as you say, there will be mostly the same structure, or at least the Commission expects the same structure to be present in most of the European regions. And I would say that what is in our experience, in your experience as a manager of the Regional Digital Innovation Hub, the main interest for ICT companies? So what did your structure do to tailor to the ICT? I mean, you already mentioned something in your presentation, so if you can.
Yeah. Basically, I just recall what I was saying before. One of the basic interests of the ICT companies, of course, is matchmaking. So market opportunities, business opportunities. So especially with that service that I was presenting before, there's a great opportunity for getting visibility for ICT companies. So entering the demo labs. Okay, but this, of course, it's a two-way process. They give us something, we give them visibility, and they give us also some trainings about their technologies. So it's let's say it's a two-way interaction processes. What should I say about the interest in the ICT apart from matchmaking? What is not the interest, but what we experience, it's that their attitude, it's usually very different from the, let's say, users. Users are quite conscious of their gaps, and they come to us asking, help me, basically. And ICT companies are very confident and usually are not perceiving their gaps. And specifically, I would say that we noticed that they have quite usually a gap in communicating their solution, the potential of their solution. So it's quite useful to interact with the Digital Innovation Hub that knows very much the demand side, very well the demand side, and can help also the startup or the ICT company to communicate better the potential of their solution. Basically, we notice that this can be a good, let's say, point for them to interact with us. Apart, of course, of accessing also some very specific knowledge and capacities and help and support.
Okay, thank you. Yeah, I think it also has something to do with the size of many ICT companies, which are quite
small usually.
Yeah. Okay, fine. We have another question, which I think is for most of you. So we are asked, can one have access to the use cases via Paolo? And I would say, as I said before, that the materials will be made available on the event website, and you will have direct contact to all the speakers, which I think will be happy to respond to any request, and also to show a bit deeper or have some demo on the use cases that they presented today. Harald was also mentioning that the Visplor tool is available to test. So I would say just don't hesitate to contact any of the speakers. You will find the contact details in the slides that we will share. Or if you want, contact me or contact Paolo to see if the request was mentioning the use cases that we already have collected as a digital innovation hub. Yes, you can definitely refer to Paolo to see what we already have. And please, you're very, very welcome to also contribute. So to contact the IP4FVG, the website is www.ip4fvg.et. Maybe we can put it also in the...
Yeah, unfortunately, I do not have it on my slide, but...
No, and so really the interest is on both sides. So let's see if there are some more questions. No, I think we answered most of them. It's almost 6 o'clock. We are the last session of the day of the workshop, so I guess.
Yes, sorry, Stefano, I posted our website on chat.
Okay, so then we will also share it on the slide, so that also the audience can see. And as I said, thank you very, very much once again to all the speakers. We hope that this session has been interesting, that we have given you something to think about. I personally enjoyed the use cases. I would like to have many more questions, both to Harald and to Alessandro, because also the bakery video was also interesting, also from a visual side. I mean, the defects were quite different from what one usually sees in a normal industrial environment and factory. And also for Allard, I mean, I think that the tool you showed us, you just gave us a glimpse, but one could see that there were many, many more functions, and that a lot of work has been put into the tool. So please feel free to contact any of us for any requests or any other questions. Thank you very much. And let's go on tomorrow with the other workshops and the other B2B sessions of the software days. Thank you.
Thank you.
Thank you.
Thank you.
Have a good evening.
Bye-bye.
Bye.